All right, new problem. Integral from 0 to 3 of 1 over x minus 1 to the 2/3 power. So you might be wondering, well, you look at this, why is this improper? Well, something funny is happening at 1. If you try plugging in 1 into a function, you get 0 on the bottom of a fraction. 1 divided by 0 doesn't make sense. So inside the interval that we are integrating over, we have some funny business going on. Our function is undefined at 1, and 1 is in our interval. So what's going on at 1? Well, we have a vertical asymptote at 1. So this is a graph of 1 over x minus 1 to the 2/3. We're supposed to be finding the area under the curve from 0 to 3. So we want all this area, and we want all this area. Start at x equals 0, go out to x equals 3. What we see here is we're going to have two improper integrals. We're going to want to split this up into the integral from 0 to 1 of 1 over x minus 1 to the 2/3 power plus the integral from 1 to 3 of 1 over x minus 1 to the 2/3 power. So we're going to find that area using an improper integral. We're going to find, so integral from 0 to 1, and then we're going to find the integral from 1 to 3. If either of these integrals is infinite, we'll say the area under the curve is infinite. We'll say this integral is divergent. So we got to do the limit as b approaches 1 from the left. So we're approaching, for this integral here, we're approaching 1 from the left side of integral from 0 to b of 1 over x minus 1 to the 2/3. Then we're going to take the limit as c approaches 1 from the right of the integral from c to 3 of 1 over x minus 1 to the 2/3. So for this integral, we're going to start at 3, and we're going to take the area under the curve, and we're going to move c to the left here to 1, so we're approaching 1 from the right. All right. So this is x to the negative 2/3. I want an antiderivative of x to the negative 2/3. Well, I should start with x to the 1/3. If I subtract 1 from 1/3, I get negative 2/3. Wait, but if you're taking a derivative of this, you got to bring down a 1/3. We don't want that. We should multiply by 3. 1/3 times 3 now is 1, so there we go. We'll lose the constant, and we will, oops, I'm sorry. This should be an x minus 1 to the 1/3. There we go. Now if we bring down the 3 and 1/3 cancel. Well, negative 2/3 there, and so we'll get x minus 1 to 2/3. All right, plug in b, plug in 0, and subtract. Over here, so similar case, limit as c goes to 1 from the right of 3 times x minus 1 to the 1/3 power. Plug in 3, plug in c, and subtract. All right. So here we have 3 times b minus 1 to the 1/3, and we remember 1/3 power is the same thing as cube root. Minus 3 times 0 minus 1 to the 1/3 power plus the limit as c goes to 1 from the right of 3 times 3 minus 1 to the 1/3 power, in other words cube root, minus 3 times c minus 1 to the 1/3 power. All right, so as b approaches 1 from the left, what's going on here? Well, 1 minus 1 is 0. Cube root is 0, 0. 3 times 0. Okay, that was rather boring. Over here, we're getting negative 3 times negative 1 to the 1/3 power. In other words, negative 3 times the cube root of negative 1. Well, that's negative 3 times negative 1. So the cube root of negative 1 is 1. Or sorry, cube root of negative 1 is negative 1. So, over here, all right, as c goes to 1 from the right. All right, so this guy right here, we have 2 to the 1/3 power. So we got 3 times 2 to the 1/3. Over here, c goes to 1 from the right. All right, 1 minus 1 is 0. Cube root is 0, 0. 3 times 0, 0. Okay, so that guy's gone. So we end up with 3 plus 3 times the cube root of 2. If you wanted to give your answer in radical notation. You don't have to. You could have left it like that.